Some time ago, we made a power bank in C4 shape. Got a lot of support from the audience. But some friends said, "You're afraid to use this thing. Charge it up outside and you might get an orange." So this time we did a convergent one. Tape the battery with Highland barley paper. Install the battery holder. Turn on the spot welder. This is a single 6-string. Follow the connections in the video. Notice here where the pole U comes on. Refer to the position of the shield pad. This is what it looks like after the welding. Wipe down the back of the shield. Apply nanotape. Pay attention to the positive and negative poles of the protection of the battery. Glue the protective plate to the battery. It's pretty good. Next comes tinning of all kinds. Here's the cable that connects the shield to the battery. This is the pole ear and the intermediate node of the battery. Connect the protection plate to the battery in sequence. Finally, measure the output voltage. No problem. Plug the XT30. Protect with heat shrink tube insulation. Connect the wire to the protective plate. Don't skimp on the solder here because of the high current. Beat a patch for a long time. This time we don't have to rub the board by hand. And why did we do this last video? The resistor on the chip is used to change the number of battery strings. I welded the jumper myself. It's ugly. The 4-ohm OS chips on the motherboard generate a lot of heat, so we need to heat them up. Put a heat-conducting silicone pad on the back. These thick thermal pads are for insulation, because there are 4 more components in the back of the motherboard. Fear of metal short circuit. Attach screws to the 4 openings on the motherboard. Fasten with nuts. This one is an aluminum substrate. It is the same size as the PCB. Here tighten the 2 screws of the interface with nuts. Attach the remaining 2 screws to the studs. Attach thermal conductivity adhesive to the back of the heatsink. Glue to aluminum substrate. This is where the circuit is done. Plug in the battery and test it. Charging power can be up to 100 watts. Peel the protective film off the acrylic. Here we need to use a power drill to chamfer. Find the largest area. The bottom panel has 6 screw openings. Use a small number of electric drill to slowly grind. Be careful not to enlarge the inner bore. Otherwise, this piece of acrylic may be scrapped. Don't ask me how I know that. We can use the low RPM of the drill here. Don't press too hard. Don't rush. Be patient. Screw like this above the acrylic plane. A little pinch will do. Here are 4 screws and 4 nuts. In the 4 openings on the side. No need to install the 2 center openings. Put the screws on first and hold them down with your hands. Screw on the nut again. The other 3 do the same. If the nut is crooked, you can straighten it with pliers. So the screws don't stick out as much. You can act as a foot pad, prevent scratching of acrylic. Wipe the inside of the acrylic clean. Secure the circuit board with 2 screws. That's why the bottom panel has 6 openings. The reason for only 4 nuts. Mounting front panel. Screw in. And attach the side panels on both sides. Apply foam single-sided adhesive to batteries for cushioning. Install the top for nuts. Wipe the inside down. Put the battery in. Install the rear panel. After the back version of the screw is tightened just enough to hold the battery and the circuit board, this increases the structural strength. It also reduces the need to plug in and plug the pressure of a screw holding the circuit board. Connect the power supply line. Cover the last acrylic sheet. Screw on. So we're done. Take a look at what it looks like. Weighs 896 grams. I believe seeing here, some of my friends have already. I'm ready to go. Some of you may have questions. Where can we get these materials? Don't worry, let me explain everything to you. Power bank, batteries, of course. Batteries are also in the pile. One of the most difficult materials. The battery on a treasure can be said to be mixed. Some are dismantled and some are refurbished. Have everything. The battery I'm using here is 26,650. A single one is 5,000 mAh. This battery is supplied directly by the manufacturer. It's a salesperson from a previous battery. See my video and contact me. The final deal was 200 pills at a time. $30 a pop. Of course, this price is not very cheap, but it's the original factory. Of course, when you buy your own batteries, there must be no cut in corners, because these 6 batteries have to withstand 100 watts of power. The battery is so bad that it can catch fire or even explode. Next comes the shell. Because Sha Yao, you and I are both office workers. I don't have time to learn drawing software like CAD. So we called an outside help. This is the Lord up. First edition drawing. We're using a notch in non-fix. However, the laser cut inaccuracy of acrylic is 0.3 mm. But I'm worried that this 0.3 mm difference will cause. The housing cannot be framed by the nut. This will make the nut spin when you turn the screw. Just when we were at a loss, Sha Yu suddenly took out such a thing. It's called a 6-sided nut. It has tabs on all 6 sides. With this thing should perfectly avoid the processing of the work. Drawing done. After that, it needs to be mass-produced. It's one of those things that makes my blood pressure skyrocket. First, I was at a treasure, found an acrylic processing shop. The price we talked about was $70 for 4 sets, and then after the drawings were given to them, they said they couldn't make the side sink because the hole is too close to the edge and easy to break. I thought I'd let that go. Just do the top and bottom panels, and then after a while, he said he couldn't do the top and bottom panels. then tell me to go back and change the drawings. Then I thought, oh, forget it. I'll come back and drive it myself. I waited a few days after I paid. It's a fool to get a delivery. I've only one said, and then we find him. He was giving me all this crap about 4 pieces for $70. That means only 4 pieces of acrylic. And then you're pulling it around here, and I don't want to waste time with him. I just called. After a while, obediently agreed to return the refund. This man is a bitch. I understand him. He, in turn, thinks I'm easy to buy. Push your luck. Take convenience for granted. The most irritating thing is this store search ranking is still extremely dependent on money. Is there still a rule of law? Is there any law? After what I've been through, the work of mass production of the shell will be in charge of Sha Yingyu. After he ordered it, I got it delivered and found it missing a gun. But after the seller told him, he reissued it right away. No nonsense. Next comes the core motherboard. This motherboard was designed by Sha Yu. There is also open source at Litron, but many of the small partners who have done it themselves have said, "You really think highly of me." The reason is the manual patch. It's not an easy thing to do. The first is to plant tin, point by point with a needle. Let's not talk about that. It's mostly used to grow tin nuts. If there is a gap between PCB and tin mesh, then the scraped tin will spill over. If the tin mesh is not cleaned, the hole was blocked. There's no tin at the corresponding part position, like this one is. Then comes the most time-consuming part of the decoration. It's not the pendulum that's the trouble. I'm looking for components. Because the board space is limited, not every part has a private print. Go to the computer to find the corresponding part components. And then we have to look for one of these bags on PCB. That's not the worst part. I don't magnify these components. Can you see the polarity? There's also this clip-on element quivering, and all of a sudden it's kind of on edge. We usually call it a monument. That's what we said in the previous video. Been a patch for a long time. So this time we're not gonna rub the board with our hands directly with Zhang Lehong as SMT. The process is from placing components to pasting. Sheet welding is all done by machine. Artificial patch, it takes a long time to find components. Just take this off the tray and put it on. The point is, he's not wrong yet. The final reflow welding, just run it over the conveyor belt. Simple as that. Take a look back at the plates you've welded. The child. Before there has been a small partner in asking how to place an order PCB for nothing. Now let's welcome Sha Yu to explain. First, open our open source link. Find schematics. Click to open in the editor. Click the file in the top left corner. Export bond table. Return to the project details page. Find the board design in the PCB section. Click to open in the editor. Click on the file in the top left corner. Type the Gerber file and the coordinate file respectively. Open GLE Set a single assistant. Click on the lower left corner to place an online order. Upload the Gerber file you just exported. Select the number of boards according to your needs. Confirm that the production draft is selected according to your needs. Then choose the color you want. Specify the location and add gas editing. You can also choose according to your needs. As anti-patch option selection required. The rest of these options I choose according to my actual situation. After the order is approved, you can place an SNT order. Upload the previously exported BOM table here and coordinate file. Click Next. Here you can choose whether to stick only the top layer or the top layer according to your needs. Full, bottom, standard or economy type. Preview screen on the right. You can see the board straight through when it's welded. The orientation and position of components can also be adjusted. The left column allows you to select either replacement components. After editing the components, this needs to be confirmed one by one. Direction and position of components. After the components are all confirmed, click Prepare Finish. The project was designed with EDA, so I'm going to choose item 1 here. Finally, click to confirm the order. There is also the IP5358 chip. Garetron doesn't have that. You can buy it yourself and mail it to the factory. They'll put it on for you, so I don't have to come back and post it again. We have it now. It is the motherboard made by Jolly Huang SMT. I welded this little resistor myself. You might want to change it when you get it. It is a jumper that switches between different battery strings. The motherboard can support a battery pack of 2 to 6 strings. Motherboard open source link, acrylic drawings and bill of materials. I'll put it in the board in the comments section. You can pick it up yourself. Then I'm Technology Yu Chen. I'll see you in the next video. Bye.